Alright, we're back. That took a little bit, so I think the video is there. At least I see that. I'm not sure about the audio. I'm curious if the audio is there. Alright. Okay. So anyways, where were we? Let me have a sip over here. So we were trying to figure out this pattern here. So I was asked while I was off air for a little bit what that is actually for. So this is for that, for these guys. So if you see this pattern of the vias, this square that I'm messing around with is to lay out these around so that they're in a nice even pattern and they are easier to lay out. And we will be using footprints to set it up. So there we go. Alrighty. Let's see, can I have a second window here? Where's my profile? Where is it going? Twitch. And then let's go here. And yes, there we go. Okay, so that's that, and the chat is here. Good, so I can close this. And okay, so there we go. So let's go back. We were here. Yeah, let's continue laying these out. I should be able to just select this and this, and how many? 1, 2, 3, 4, 5, 6. Can do 7 probably. Let's do this. 1, 2, 3, and 4. And then let's create an array, and it's 1 horizontal, 7 vertical, horizontal spacing 0, vertical spacing 0.9. Yes, correct. No offsets, no stagger, and okay, wrong direction. Let's do it again. And then create an array, and offset is -9. And okay, there we go. It's much better. So now we have one excess. And delete. So also what is happening here is that there we go. I want KiCad to not do this. It's like I want to select these, so if I start dragging, don't drag the element that I'm in. It's like, I know it's not easy to infer what I actually want, but just guys do it. Alrighty, so let's we will have to select all this stuff by hand. Yeah, the old canvas has a few advantages. One of them is that selecting groups of elements seems to be a little bit easier, unless there is a modifier key for this that I don't know anything about. And if you know of it, let me know. Okay, so this and this. We're just selecting all of that. Yes, that one more. And then let's move the mouse. And move. And there we go. And delete. And delete. Now we can create a copy in the other direction. And then duplicate. And we go reset and 4, 5. Bam. All right, very nice. Let's I'm curious actually if I hide footprints front, and now I start doing a selection. Now it works. So I can hide the footprints, and then it will allow me to select the stuff. Very nice. And then shift, and that's very cool. Okay, so there is a way of doing this. It's a little bit unintuitive. Duplicate. Oh. And now we go here. And enter. Okay. That's very cool. Okay, we have now our pattern. There's something missing here. Haha. And then duplicate. There we go. Perfect. Now footprints enabled. There we go. Yeah, so now we have the pattern. Oh, it's one more. Dude, okay, there we go. Duplicate. And then 4, 5. There we go. Now it's complete. Okay, so next we should figure out if we are routing it. Should we start with these, or should we start with the complicated stuff like the USB, or should we start with the really simple stuff like the powertrain? We should definitely move this guy. So where was this stuff? It's like, so I moved this LED because I wanted to figure out if I can move it next to the button, and maybe even swap positions between this stuff here, PA8, and the button, or like move this stuff over there. But the reason was that I connected it to PA8 was actually, if you look into the schematic, PA8 is this guy. So this one has a timer channel on it. So we can do nice PWM fading on the LED. That is pretty nice. And if this was the thought I had. So basically, the LED is connected to PA8, so that has PWM. I was thinking that I could move it over here and connect it to PB2 instead, and maybe even get rid of that pin. But the problem is PB2 is just bare. There is only GPI on it. There is nothing else on this. The question I have, why the hell does it have a pull down now that I look at it? Was there something on there? Oh, I think I know. Let's do this. STM32 F4 05 data sheet. Will that yield the data sheet? Yes, there we go. So let's look at the pinout. Let's go down, that's lower. Yeah, we have to look at the pinout here. So that's beyond the, yeah, there we go, footprints, and yeah, there we go. PA, so this is PB2, that is at 28. So 28, so LQFP 2, yeah, the 64, 28, 28, there we go. Yes, so that's the boot pin. There we go. So this is boot 1 actually. Boot 1 is just a modifier, a minor boot modifier. You usually use boot 0, and the boot 1 is usually pulled down. If it is pulled up, it has like some weird mode that I never used. Okay. Oh, good. Welcome back, Bob. I'm glad the audio works. It's all an experiment, and I hope that this time the video gets archived. Okay, so let's go back. So yeah, I decided not to connect. Let me finish the thought that I started here. It's like Bob was looking at this stuff, if you didn't see the first part of what I was showing, I think now the video will be archived. So it will be possible to watch my Twitch broadcast later on as a recording. So if you have any interest in doing that. All right. So let me have a sip here. Yeah, if you talk so much, it really dries out your throat. Alrighty, so we have the button, and the button is actually connected to this pin down here. So a nicer thing would be if the button would be here in this area. But the problem is that the LED would need that space. And I don't really want to move the LED up here. That might be closer, because then it is covered with the connector from JTAG that is like in this whole area here. Yeah, problems. Yeah, I think I will just leave it as it is. I did manage to get the ground and the 3.3 volts and the VBAT pins actually in here. I had to move this GPIO, so PC1 and PC13 are in the center here, as well as PB2. So PB2, as we just discussed, is quite a semi-useless. So I still want to expose every pin that the chip has to offer, or use it for something. So I still want that pin. PC1 is not very useful. It has some ADCs on it, but it's not like a hugely function rich pin, just like PC14 or PC4 and PC5. So, but these are in different places. Oh no, here, look, they are PC4 and PC5, there we go. They're in good company, so this whole row is of just ADC pins that are only semi-useful. There we go. Then we have no, this is PB. Start reading, okay. So PC5, PC4 are useless, and then PC1 here is quite useless. Anyways, so PC13 is actually, compared to the PC1, PC4 and PC5, actually much more useful pin, because it has the anti-tamper stuff in here. So I think it is used to indicate if so you put a read switch or something in your case of your device that you develop, and if you even if the MCU is sleeping, so it is using the 32 kilohertz oscillator in a battery, this pin, if it is being triggered, even in low power mode, it will realize that. So you can basically use it to detect that someone was tampering with the device itself. So they tried to open the case of it. And then RTC AF1. I think these are for the real, like, alternate functions of the RTC. I didn't really read much into that datasheet part because I never really was interested into this whole RTC stuff, but maybe someday if it's useful. So anyways, let's go back. So PC13. So these pins are the, like, stuff that I can live without having it on the breadboard pins that are on the outside here. So I'm fine with them being here on the inside. So even if you don't always just connect them, that's fine. But they are exposed if you need them. So yeah. Anyways. So what next? We were looking into the LED. So I'm talking too much and not getting much done. So let's do this. So there we go. That was the previous design. So I had the LED sitting just next to it, and just above it was the resistor. All right. So let's move that guy. Why am I changing the grid here? Okay, there we go. And took footprint. That's the wrong thing. Footprint. There we go. Move. This should be just lined up. Oh, we are in the wrong grid. Let's go on down. I should learn those shortcuts to changing grids so that they are directly in my muscle memory, because they currently are not. So yeah, that should be good enough. And then this footprint, move and rotate it. Okay, let's make some space. Let's have the courtyards not interact with each other. Is that now above? And yep, there we go. All right, and save. Okay, so now we can, I think, start routing some stuff. So VBus. So we had vias here actually in the previous design. I completely removed all the routing. It's like, I'm not sure that was the greatest idea, but I did that. It was such a mess because I moved the microcontroller just by a little bit to the left, and it disconnected all the traces. It's like, this is the annoying part about the OpenGL mode, I think. I'm not sure even the classic mode can do that, where you keep the traces still connected. I bet this would explode all over the place anyways, so even having it moved with the traces attached is probably not a great idea. But yeah, anyways, we have to reroute the whole thing. I don't think this will be too much work though. It's quite straightforward. Okay, so B and go, and yeah, so this is letting up. Yeah, I want... What are you doing? Why are you... Oh, it doesn't want me to move this guy on top of this pad. Interesting. Okay, so let's do use. Yeah, there we go. So with the... what is it? D drag, yes, D. Yeah, it's, see, these things are already muscle memory, so I don't even know what letter they are. So drag D will just allow you to drag it over the pad, but if you just try to use the push and shove, it will not allow you to do that. That's an interesting thing. I didn't know that. You always learn something new. So let's do that. Yeah, There we go. The via is here, but it doesn't let me, so let's drag it. Okay, and there we go. Should we? Oh, I think I had it just like that, just poking out a little bit. Maybe I shouldn't do that. So let's just do it to the edge here. That's nice. I like that. There we go. And another one, and dot, and do, and escape, and drag. Let's put it here. Very nice. And page up. Okay, so this one can be just dragged here, and then here, and then on the back side. Yeah, I probably will have to drag this away, unless I think I had it on the other side. Let's see. So VUSB. Oh yeah, so the previous design is actually completely gone. Yeah, I had these already routed in the meantime. But what we could do is basically have a via here and go. Yeah, magic, and then just connect it to here. That's nice. And then let's do the VN stuff. That's easy. And then this guy. Yeah, like that. Is that even? I don't think this is even. There we go. Are these corners even? Yeah, there you go. My OCD is completely coming out here. Yeah, so I think that is even. Okay, and then VN can go here. Okay, good. I like that. That's nice. Okay, now 3.3 volts. We need to get it into the inner plane. So on the inner layers, we have the 3.3 volt stuff. So that's not a big deal. But it needs to be connected, and we have ground here. So I see. We have here the stitching vias that are actually components. So there is one of them. Yeah, in the previous stream I was talking about that, how I do these. Move G, use G. That didn't work. I don't know. It's like I tried G. I tried everything, but it's somehow. Maybe on smaller components that have less connections, maybe this is when it works. G. Okay, I have it selected, and then G. Nothing. Doesn't grab it. I don't know. They are not rectilinear. Interesting. But it is in the classic mode, or it's like so in F9 mode? So grab. Yes. There you go. So that's the difference. It's like it works in the legacy mode, Bob. It does not work in the OpenGL mode. So that's what I'm using all the time. It's actually the F11 OpenGL mode. Yeah. So you have to go into the legacy mode to keep the stuff attached. So it behaves the same way as Eagle actually does. When you actually move drag a component, then the traces are staying attached, and they just are all over the place. They stay attached, but they are still useless. Still, you have to completely reroute the stuff. I wish basically that KiCad would use its awesome push and shove algorithm to figure out how to keep a component attached. I understand if you have a monster like this that it might not be possible, but if you have a resistor or a capacitor or even a USB connector, this should still keep these traces aligned. So if I do like trace, it's like it's nicely attached and it's doing all this nice squiggly stuff, but it's not doing it if I drag a component. It's dumb, and I wish it could do that. I hope that the CERN guys that actually developed this algorithm, they will be able to add that eventually to the code base. So yeah, there we go. Let's add this traces here and 3.3 volts, and yeah, let's add a via here, and just in the middle here, whatever. Then we have this one. This is the like regulator capacitor. It's like I don't even remember what it does. It's like I'm copying this linear voltage regulator circuit since quite a while from one schematic to another. Then we have the boot, and the boot pin, and then we have this nice thing from the back. We can connect here. Oh, there we go. So now we have to get the USB traces actually out of here, and things become interesting. So yeah. Whew. Let's do that. And then, so yeah, this would be the trace. Do we want to use this one or this one? Let's use this one. I'm curious if that works if I'm using the this pattern here for keeping a nice pattern for the vias. It's like it probably will start moving my stuff around. So yeah, this one. Ugh. Wrong side, page down. There we go. There we go, and yeah, so duck. Oh, I'm in the wrong mode. Let's go into shove mode. Shove. And boop, and there we go. Yeah, Indiana Jones. Yeah, we will use this guy. It's because we have one spare. And then we go. And go. Wrong. Yeah, we can use slash to actually change the modes, but I'm too lazy. And page down. And no bueno, no bueno. What do we do here? What do we do? We could actually move this one. Let's try this. Move this one. Move this one. Let me think. Like this. Just to have the other line empty. Okay, and then go here. And will this work? And then let's use this via. Let's try it. Okay, and now move this one, and yeah, this is, there you go. It's like it's all over the freaking place. Yeah, come on, just stay here. Oh, because I'm tracing it here. Ah, I'm trying to get between them. I see. Yeah. I'm being mean. It's like I'm being mean, trying to get that in through here. I see. Okay. Well. So far so good though. It's not a terrible thing. Okay. Yes. Yeah, let's just violate here the rule and have this guy like here and this guy like here. There. So this one is offset a little bit, but it's using my pattern so far. We could also move this stuff closer. Yeah, we have the V-bus stuff still here. So okay, so next thing, B, U, and then U. All right, there we go. And then page down, and let's try this. So yeah, this is the problem. It's like this VBus stuff is here on the other side of all those traces. I might need to move this stuff. So this is an interesting part. It's like this is the jumper on the back that connects VBus to the boot circuitry. So you can select if when you plug in a USB cable, if the STM32 should go into its built-in in ROM built-in bootloader. This way you can flash a firmware without the JTAG in the field or something. The disadvantage is that the chip will, every time you plug in a wire, USB wire, it will go into the bootloader mode. So anyways, it's a trade-off. With the JTAG, you can program it whenever you need to and use the USB port for everything. And if you want to just flash once and then use a different source of power supply or remove the jumper, you can. So yeah, there we go. Yeah, so let's see if we have this. So this has to be connected to this guy. Do I have enough space here to squeeze it in? Not really. Yeah, let's put it here and place. Okay. Yeah, that's not. There we go. Yeah. Yeah, I'm not sure I like it. I think I might actually do some different things here. It's like we wasted just 2 positions here. That's not nice. Yeah, well. Then we have PA8 that you will have to find a way to here. And we have all that JTAG stuff too. Oh, great. Oh well. Anyways. So that's it. Anyways, I think we will end it here for now. It's like I want to see if the recording works. I hope this was like somewhat interesting what I'm doing here. I might start doing some more streaming in the future if this works out. And this was another experiment. And yeah, I talk to you soon again. Have a good one. Bye.